Yash here, a fellow dev whose daily routine is full of writing codes, building projects, and creating systems which help other devs, people, businesses, and communities in their work and day to day life. And in this journey of sleepless nights and crazy weekends of development, we as developers always have a companion sitting with us, tracking every activity and monitoring every single minute change happening in the code. That's our Git. But that minute change has recently become around 6,488 lines of code, or maybe even around 5,000 plus lines of code. How are we over here? These commits are full of changes, bug fixes, integrations, which no one knows what happened in those, to be honest. Like, even as a developer, I don't know what happened. How did we ended up over here, though? Maybe it's because of this. That's where we introduce you VibeGit, a platform where you can safely wipe code and be careless about commits. Over here, you prompt and we commit. Now, you'd be saying, why to commit? The reason to commit is because a commit message is full of multiple information which is structured in a proper fashion. It has changes. It has what happened before. It has what happened right now. It has what happened next. And it has all the insertions and deletions. A commit message is a structured understanding of what this developer was trying to build. That's why a structured understanding of a change is important for an LLM to understand what to do. Over here, as we saw, we can select our desired tech stack and start coding. We maintain a Git history over here, and at every prompt, a commit message happens. But is it just a commit message? Or is it more than that? I would say, yeah, it's more than that. We don't just write a prompt, send it to an LLM, and generate a response. Rather, what we do is we perform first a retrieval, a recursive language model based retrieval, where it searches the codebase and the Git commit history to figure out, is there anything I have about the same topic we are working on? For example, you were working on auth maybe a month ago, and now you have a bug fix. You have to add some kind of a problem in that, or some kind of a more feature, another new feature in that. This retrieval will figure out the previous commits, the changes which happened over here, and then will add them into the context of your current prompt. This way, it knows what you have tried, what you have kept aside, what you are doing, and what you did. This way, it does not hallucinate and does not have problems generating the same response again and again and again. But getting so much history and so much information into a context, won't that bloat the context itself? That's where our second layer comes in picture. That is token optimization, where we compress your tokens from the existing large understanding to a smaller understanding. Over here, we can find there was a 2.1% compression, and the total saved tokens are 690. You went from 1320 tokens to 630 tokens. But doing this, you also optimized your prompt so that it's a markdown file with a proper understanding of what we are trying to build. What do we have over here, and what is the requirement, and how to do it using proper instructions and information. You did not just increase the context, but also improved your prompt in this process so that you get better results. After that, this prompt goes to a generation LLM model. Over here we are using OpenAI key, and then it generates the answer. But do we stop there? No. We have an evaluation mechanism which evaluates what is this generation exactly what we asked for. If it satisfies the threshold, it stays. If no, there's a retry, and the system again tries to build new information. Oh, but that's not it. We also have a self-correction mechanism where another LLM tries to be the judge of the current LLM generation and figure out is it a good answer or a bad. In this way, we have a self-correction loop where we can improve the understanding and generation of prompts, code, and retrieval over the span of time. This does not just improves generation, but also improves you to add more context into the system and have better understanding of what we are trying to build. And then finally, we commit all the changes into a commit, which can be seen over here. But what do we have in this commit? Oh my god, that's nothing. 3 files with bare minimum changes. We don't have around 4,000 lines of changes in a single commit now. We have something which a person can read, which a person can understand, and which a person can believe have happened in that time. Something which is measurable and something which is maintainable. This is what we pitch. Instead of you fighting with LLM for hours and hours trying to figure out this, trying to do that, and in this process of trials and errors, creating a long change layer, changing code base, we provide you this. Where if it works, it's committed. Where if it fails, it's not committed. This way, you have a better understanding of what actually was the developer trying to build and what actually happened. This way, you have actually minute changes tracked into the system, helping you and other fellow developers understand what actually happened. And in this process, trying to increase the accuracy while decreasing the tokens.
FBI, open up!
Over here as well, we have a simple change with a simple git def and an optimized answer with 5.2% compression. It literally compressed so much. In this process, you're not just generating better answers, you're also giving some benefit to your pocket. Maybe save that for a cheat meal later on. This is what VibeGit is for. For you to vibe code safely without taking care of committing every single time and tracking those minute changes, while also not taking care of having a proper prompt and an optimized compressed prompt so that you don't get the bill of thousands of dollars. This is VibeGit. We have a matrix and keys where you can save your OpenAI key, which can be used for this generation. So you keep your security with yourself. With that, we also have some themes which you can work with. We have this option. We have this option. And if you're a Minecraft villager, we also have this option. You choose what you like, but what is important is over here. The total number of commits, the total success rate, which is the amount of commits were actually above the threshold, the average compression of the tokens, and most importantly, the number of tokens you saved in this process, which is in just 2 commits, is around 1,845 tokens, which is a big number when it comes to a complex project with complex file structure and n number of numerous understandings which we can maintain. This is where we create a change. We also have a self-correction score which improves the generation of the prompts and retrieval, eventually making it a self-sustainable product for your own system. This is VibeGits, and here I'm Yash, trying to help you vibe code in a more and precise fashion with my team. At the end, I would just say, keep vibing, keep coding, and just try to build crazy projects with this technology so that you are not just saving tokens, you're not just saving money, you're just not saving time, but you're also increasing accuracy while vibing. Thank you guys. That's my presentation. That's our demo. We are from Code Crayon team, and this is what we present to you, VibeGit. What do we have over here? Let